0 belongs to P. This is the 0 of B, right? And for and so now I'm going to write a sentence. If you take any P and Q in P and take any lambda from R, then P plus Q and lambda P both belongs to P. Okay? Then I'll not prove this. This is one of the exercises, and we shall see this later on also. Okay? So, you see, what am I doing? That's the principle. I want to show P comes in with this notion of addition and so on, but I'm trying to put it inside a bigger picture, which I know from somewhere else. Okay? Then this comes. Okay, and then the final one, 4 minutes more. Okay, the final one is another, it's an exercise, but it's also one of my favorite ones. It just shatters the idea that you shouldn't think of this addition as really an addition. Okay? So it's just an example, very educative in the sense that it tells you what to look for, and secondly, it also whips you in the way that it says that vector addition, don't in any way think of it as an addition of usual numbers. What is it? My set is R, not R positive. Okay? This is an exercise. It's given there. I'll state it. Okay? And quickly go over it. Now, what is my vector addition? So it's a binary operation, right? I take the multiplication. You already see it's commutative, associative, has an identity. What is the identity? 1. And what's the inverse? 1x. Right? Good. Now I have to define all the first 4, that goes away. I have to define the scalar multiplication. It is x to the power lambda. Okay? Let's look into this distributivity of scalar addition. So remember, what do I have to show? Lambda plus mu times x is lambda times x plus mu times x. Okay? Now, let's see. What's, by my definition, what's this? this is x to the power lambda plus mu. Right? Okay? This is the definition. Right? Lambda times x is x to the power lambda plus mu in this example. Now, what do I know about this? This is x to the power lambda times x to the power mu. Okay? But what is this multiplication? This is actually the vector addition. So this is, shall I write this in this way? To make, if you want, right? But what is this? This is my lambda times x. Mu times x. I did one, so you see. Okay? So this is then actually this thing. Okay? So this is a beautiful example. So it is actually the laws of indices which is telling you about this distributive laws. Okay? So you must, so this is where I stop. Okay? And we believe we meet after 10 minutes.
Last time with a circle around.
Yes, because I said if you want to make the distinction.
Yeah.
Okay? So we meet after 10 minutes for our practical or tutorial session. Okay? Okay. Zero vector and the scalar multiplication distributes over and so on, right? So it becomes an example of a vector space for any set X. Okay? In particular, if I take the set to be the set of all real numbers, that's a vector space again with that same addition. If I take it to be the 0, 1 closed interval, R to the, that's again a vector space, not the 0, 1 closed, the functions from 0, 1 closed interval to R. They become a vector space, okay? And that's how it fell out of that condition, right? Now you said about, you could see Rn pretty well, you said just now. Okay. You can visualize, yes, here is the connection that I am saying now. Now, think about R1, which is R, right? Yes, you drew that line, it says yours. Okay, but I can think of it also in another way. How is it? I can think of each real number as a function from the singleton set. So this is a set which has only one element into R. Now what is the function? Well, if I have to give a function, then I must tell where this star must go. And it can go only to one real number. Okay? So the real number A can be thought of as a function from the singleton set to R. Okay? What about R2? Well, you can think of this as a function from the two-valued set. Okay? Why? Well, you will tell me where 0 goes, and you will tell me where 1 goes. So giving me an ordered pair of real numbers gives me a function from a two-valued set to R. The first coordinate is the image of 0. The second coordinate is the image of 1. Okay? So generalizing in this way, what is Rn? You look into the set which has exactly n elements, and if you give me this n tuple, well, what is this function? It is taking I to xi. Okay? All right. Now let us see. How was I doing? Well, this one is trivial, the addition. How was I doing the addition over here? A, B plus C, D is A plus C, B plus D. That means adding at 0, A plus C is the value given to that at 0. B plus D is the value given to at 1 with point-wise addition. Same with Rn. Same as the scalar multiplication here or here. So now you see why R to the power x has this. So you can think of this as if it was an xth tuple. Yeah, I cannot write it anymore because I don't know x. This is an xth tuple, right? So where does the xth coordinate go? And where is, see, this is the ith coordinate. I going. So where does the x, where x is a member of this, right? Where does the xth, I'm saying, if you take a small x from, so I'm looking into the xth coordinate. Okay, so as if this looks something like this. As if, see, I wrote it. If I can write this as xi, I from 0 to n. So as if something like this. I am defining what will be this addition? This will be ax plus bx. So that is my xth coordinate. So that is again this pointwise addition. So now you can see it's actually a big product kind of thing. So you can say the x-fold product of R. Yeah? So this is possibly the connection. Yes. Okay? Clear? Yeah, the next one.
Okay, my last one, the confirmation that when it comes to especially mathematical notation, you are unforgiving in the exam.
Yes. Yes. Well, as I said, I'll convince you of many things, of which number one I said is mathematics is simple. Number two is, you will see these number two and number three. Number two is, I'm going to develop, I'm always going to say in terms of a very, very straight language, which I'm developing, right? I developed on the first day. There's no dual meaning to it. I do it here, I explain it to you, you understand. Anyone in Brazil, China, Italy, wherever, who understands it, reads it, gets the same meaning. So it's a universal language which has no dual meaning. And in this language, it's a beautiful language which we are going to develop. But there's something more. Symbols. Symbols have two aspects, and very two diametrical aspects. One is tyrannical and one is beautiful. Tyrannical is when it just makes a tyranny. It makes you afraid. Why are most people afraid of mathematics? Because suddenly they see strange symbols coming up and they don't speak. Right? But symbols do speak. And that's where a proper choice and judicious use of symbols is very, very necessary. Okay, so they speak. Immediately when you write, it says something. Okay? In this language, it's a language of symbols, and symbols will start to speak. So if you confuse things, that becomes a tyranny. Okay? So it shows that you didn't understand that part of it. So that's why I'm unforgiving. Okay, next. Next question from any centers also, please. Yes.
I have a question with regard to the self-assessment.
Yes.
It was number 2, association. So when proving set, maybe intersection, do you write, maybe for example, I wrote you say X in element of A and X in element of
Correct. Yes.
But then, with the parentheses that we have, how do you separate?
Yes. Yes, because and. So let's go through it. So X belongs to. So this means X belongs to. But this is the same thing as saying X belongs to A and X belongs to B, and but this statement is true if and only if this statement is true.
So you actually break it down, you don't just write the last.
Yes. And this statement, therefore, is true to this one, is true if and only if this is true. Right? But this is then same thing as saying X belongs to A. Well, obviously, initially I'm very, very pedantic about this. But remember, you started off with I'm very pedantic. You have, if I give this, for instance, if someone doesn't write this, this is the crucial step. Yeah, because this statement is true If and only if this statement is true. Okay, 1 minute. Now, I will deduct 1 mark if I don't see this. I am very pedantic. But, obviously, remember when at the next level, just like our learning languages, you start off with C, A, T, and you suddenly see it's a cat, and then you suddenly see cat and dog, and then you suddenly see read sentences, suddenly read paragraphs. Okay? So it's something like that. So at the next level, if someone says from here to here, well, I'll not bother because I know he understands this. But at this level, I will want to see this line. This line. Yeah.
I wrote the answers. My answers was number 1 and the second, but I skipped the second one that you wrote. So would it have a problem?
-1. If this is
Just because of parentheses.
No, not because of you didn't get it. It's not because of parenthesis. Because of the fact that you forgot to ascertain that this statement is true, if and only if this statement is true.
Oh, okay.
Okay? And at this level, I expect that you should get that. Okay? At the next level, I think I know that you know this. Okay. All right? Yeah.
When having a symbol, I think it's a sum for sets. Something like maybe a sum of sets intersecting one set, which maybe a set.
Kind of. Give me the problem.
When having something like this,
yes.
is it necessary to write also the other sets?
Regarding index sets, good that you tried it. I'll come back to it in my 4th lecture. Okay? I'll come back, but you give your thought to it. Okay, but I'll come back to it in the 4th lecture. Yes. Yes. It's another kind of index set is another kind of a surjection. Yes, but I'll come back to it. Yes. 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 Any further? Any next question?
Sir?
Yes.
When we were doing theorem 2, if an element Y is an element of the set V has an inverse, that whole proof, I didn't understand where Z prime times Y, okay, Z prime binary operation Y is equal to E. We don't have any, how do we know that?
Okay, you mean this statement, right?
Yes.
This proof. Okay, let's run through it again. So I have given you that Z is an inverse, so you have this line. Okay?
Yes.
Now, this line therefore tells you, what does this mean? Z prime, if Z prime be also an inverse, this statement is exactly telling you right? That's the definition of the inverse of Y. Clear?
Yes, sir.
So then the rest follows.
Okay, that makes sense. Thank you, sir.
Yeah. Next.
With regards to the last example that you made, the last lecture.
Last? Yes.
So you had the function of, we had two sets of regions. We're explaining subjectives.
Yes. Yes?
So you had a set whereby it was A, B, C, D, and the other set, 1, 2, 3. But then you didn't specify which one was set A. So, for example,
Yes, what is it?
so you didn't actually say which set was set A or set B. So I got confused in what's going on.
No, but this is the domain. So when I write something like this, and the codomain was? When I write something like this, it immediately tells me that f is a function. It tells me many things. This is a symbol. Tells me many things. First, it tells me that f is a function. With the domain of f being this one, the codomain of f being this one. Okay? This doesn't completely tell me what the function is. So this means that f is a subset of right? But when I say, what was it, FA was? What is FA?
FAC?
FA is supposed to 2.
Oh, 2, yes.
B?
3.
C?
FA was called as C.
And D?
Okay.
So when I say this further, it tells me what the set F is. So this is actually A2, B3, C2, right? That's exactly. So remember, writing this tells me so much of information just by writing that. Okay? Yes.
So just a confirmation. When you use the symbol IM bracket F,
Yes.
the image is the same as the range
Yes.
with F. Is it the same as the code domain?
No, for instance, over here, image of f. So this is exactly the set of all f of x as you vary x over this set, right? Okay? So over here, the image is just 2, 3. The codomain is not equal to the codomain.
And the inverse?
So what's the inverse? So f, the pre-image, f inverse of 2 is just A and C. F inverse of 3 is just B and D. Okay? Clear? Okay. So this is obviously image it is a subset, but a proper subset. Okay. Further, next question.
The deadline of the first assignment is approaching, And I'm just suggesting maybe we should do the index family next week so that we can deal with the question.
Okay.
Just a suggestion.
Okay.
Do that next week.
Okay,
On the index family.
Okay.
Yeah, do that next week.
When is the first, I forgot, when is the first assignment?
Next week?
Yeah, I'll tell you now.
It's next month, 22nd.
22.
Yes, so the next one is 23rd, and the fourth lecture will be in the first week of March. So it's actually every week that we are going to meet. Another fact, I heard some people asking me whether they have to pay for this video conference. There is no payment. Okay? Yes. On my side, I'm sorry I couldn't send a message yesterday because, well, UNISA systems are sometimes weird, so I'm thrown out of ICT system. I cannot log in, so I couldn't make that message. One of my colleagues actually sent you an SMS. The venues are same, mostly like this. The only exception will be this Florida venue, which will be either this or the Calavesh one. And I'll tell you exactly. And then the other thing is, it's not every Saturday. I try to keep it on Saturdays and so on, keeping in mind about students who are working. Saturdays are also clambered after by other departments, especially for practicals and so on. So, not on every occasion could I get it. Sometimes it is in the week, but if it is in the week, it will be after hours.
You mean after 7 o'clock or after 6 o'clock?
No, 5 to 8.
Which is a bit of an issue, but okay.
Yeah, I get it, but there was no other way.
Yeah, 5 o'clock you have to juggle quite a bit.
Yeah, 5 is fine because some of us are working, so we have to close and make a plan to be here.
Yes. Okay, thank you. Yeah. The monthly I'll put up the schedules every, so you have to tell me the schedule. In March you have the March schedule. Yeah. So there will be a few lectures and
I have a question, Prof.
Yes.
The videos, are they going to be available online soon at my UNISA? Because some of us won't be able to make it during the week. So the ones that you post for during the week, can we be able to access them soon?
Yes, again, no, sorry. Well, yes, they will be. Now, we are having problems. Things outside mathematics are not very simple. So this is the last week's lecture, almost 3-hour duration. It's a pretty long, big file. That's number one. Number two, the system in UNISA records it as a MOV file, MOV. But that MOV is not playable unless someone has the latest QuickTime player. Now, this latest QuickTime player, these are all strange things, and I cannot assume everyone to have it. So I was insisting and trying to have it as an MP4, which more or less everybody should be able to view. And such big files, I'll put it in YouTube, but the YouTube link shall be from my UNISA. So, and under the new regulations that have been made by UNISA, thankfully, is that UNISA doesn't always do bad things, it also does good things. So this was one which did was, well, if someone goes to YouTube videos from inside UNISA, I mean to say, you click on this video and then once you go there, you click on something else, that will not help you. So this video link which is there on my UNISA, for that, you will not have to care about the data. Okay, so that will be taken care of by UNISA. So that's, under that, even if it is a very big file, you can still download it, and it will not cost your pocket, because you are going through my UNISA, okay? And you download it once and for all, and then you can see it at your own leisure. Yeah. But yes, surely, answering your question, I hope to put up the first one by this week, and once we get an algorithm how to do this, the next ones will be very fast. But, yeah. So there are some.
Okay, thank you.
Thank you. The last week's lecture, it's a very, very big file, almost half GB. And, well, there are 3 video streams which are carrying on. One for this room, one for all those things that you're seeing over there, and the third one is actually doing the managing these two, so they don't fall out. And then there is this audio. So it's a huge file. Almost 2.5 hours it took, almost half a GB. So, yeah. Okay? All right, so we stop. Next time, please come more prepared with questions. The more questions we have, it's better. Okay.